Okay, so welcome everybody to class. I am going to be doing something kind of dangerous today. I am going to attempt to code live to try and demonstrate kind of how a project works. And I've got one student here who's not paying attention. So and we're going to start with GitHub. I'm kind of doing this for Doug's sake because he wants to use GitHub and for all the sake of his future students to try and understand GitHub a bit. So I'm going to start out by creating a new repository. And I'm going to call this repository integration. And I'm going to tell it, yes, I want a README file. No, I don't want to get ignore and a license. Of course, licenses are very important, but I'm going to delete this as soon as we're done, so we won't worry about that. I'm going to add my own get ignore file here, and so that'll be that. And we'll just hit create repository, and it goes and makes the repository. Now I have a nice little README file. And so what GitHub has done here is it has actually created a repository, and we can clone from that repository. We could download a zip file, but we're actually going to clone it. And so I have here on the left here, this is actually my lab computer that I've just logged into here. And on the right is this computer that I'm on right now. And I'm going to remove that. I don't know where my cursor went. That's kind of odd. My cursor's gone over here too for some reason, so that's fun. Okay. So, in order to clone the repository, I've already done this once, which is why I had to delete it. So you type git clone, and then you give it the address, okay? And you can find the address here. If you click clone, it'll give you the address, okay? And so we hit enter. It says it's cloning, and ta-da, it's finished. And we can do the same thing on the other side. Okay. So I want to point out that the left and the right sides here, these are two completely different computers. Okay, so there are now 3 copies of this repository. The first one is obviously on GitHub's servers. Okay, the second one is on my lab computer, and the third is on this local machine. And I'm going to try and demonstrate how we write the code, how we get it all, how we work together with people through GitHub, and handle merge conflicts and rebases and branches and all that other fun stuff. So let's say what we're actually going to be doing is we're going to be doing the project 5 again. Okay, and this is my serial implementation of this. But I'm going to make it a little bit more sophisticated. So the first thing I'm going to do is say, kind of outline what we need for this project. So where's my pen? Here's my pen. So first off, we want to be able to integrate any function with MPI. Okay, so we have some interesting parameters here. First off, integration. Where this is, since we're using computers, this is going to be a discrete integration. a numerical integration. There's a lot of ways to do that. We could use the rectangular method, which is a really crappy method, so don't do that. We could do the trapezoidal rule, which is better. It's second order. We could do Simpson's rule, which is even better. It's third order. I can't spell apparently. Simpson's rule. Okay, any function. All right, so any function could be, well, any function. So I'm going to just say, for instance, if we want to estimate pi, the function we need to integrate is 1 over 4 plus x squared. Is that correct? I think it's correct. Let me look. I've got my implementation here. Oh, it's 4 over 1 plus x squared. Got that backwards. Okay. So it's 4 over 1 plus x squared. So there's that function. Let's say maybe we want to also do x squared, x cubed, maybe sine of x. Okay. And then, of course, we have then the with MPI part. And so we need to break this down, and I'm going to break it down in this way. We have two basically completely separate tasks. Okay, one is integration. I guess 3 tasks. One is integration. One is what does our function look like? And the third one is how do we handle this in parallel? Okay, so there's 3 different tasks, and so I'm going to be writing the code to try and make it as flexible as possible because we want to be able to integrate any function with MPI. And we need to be able to choose from a range of integration options and a range of function options. So I'm going to break this down into probably 2 .cxx files. Okay, one I'm going to call the integration. I'm going to call another one functions. Okay, and then I'm going to have main, and main is going to handle the parallel portion of this. And also deciding what integration method to use and what functions to use. So let's see here. Integration, we're also going to need .h files for both of these. Okay, in order to, if we're going to be doing this properly, this is what I'm trying to demonstrate. Is use a simple idea to demonstrate how we properly code things. So let's go back to here. Oh, the other thing. Let's say we're working with a partner. That's what we're doing. We're working with a partner. And so we're going to have Platypus. He's going to work on the integration. And we're going to have Mint admin work on the functions definition. And then both of them together will work on the parallelization portion. So, over here, Mr. Platypus goes into the integration folder, okay? And if we type git status, okay, he's going to tell us we're on branch master, okay? And then we can also, if we type get k, it pulls up this handy little window here. It is showing actually 2 branches. One is master, and one is the origin, the master branch on the origin being GitHub in this case. Okay, and if we do the same thing over here on Minty, oh, can't find, well, we have to go into the repository. That'd be helpful. You can see we have the exact same thing because the 2 have not diverged any. All right, so when you start working on a specific topic, it is generally a good idea to make a topic branch. So the way you make a branch, there's 2 ways. You can do git branch integration, okay? And if we type git k again, it's going to tell us that now we have an integration branch, a master branch, and then the origin master branch. You'll notice the origin does not have an integration branch. This is completely local. The GitHub, we haven't told GitHub about the integration branch, and hopefully we never will. All right. So let's see here. So we, unfortunately, if we type git status again, it tells us we are still on branch master, and so we have to. What we have to do is we have to check out the branch that we want. So we check out the integration branch. All right. And also, if we just type git branch without anything, you'll see it gives us a nice little thing that says we're on the integration branch. If we want to see the remote branches, we can either use an A, which shows us the remote branches, or we can use an R, which shows us just the remote branches. Now, about the remote branches, this branch is in no way connected to the GitHub master branch. Okay, this is local to your machine. This is the location that your computer knows about. Okay, and I'm going to demonstrate a little bit more as we go along. So let's see here. We got integration.h. So let's open up our .h file. The first thing we need to do is put in our header guards. You always need to put these in a Where is my cursor? That is really annoying. Oh well. Oh, I need a cursor. This is really annoying. I may have to start this over. Oh, that sucks. I was messing with the preferences, and I think my cursor disappeared in the process. Okay, let's close that out. Do I get now I have a cursor. Okay. Open this back up. Sorry for the delay here. Okay, so, like I said, put in our header guards. If not defined integration H, then we're going to define it, and then we end if down here somewhere. Okay, so I'm going to make a namespace. I'm going to call it integrate. And in here, I'm going to have my trapezoidal rule. And so we're going to say the trapezoidal rule is going to actually take in a function, which takes in a double. And it's going to take in a starting location and an ending location. And that's all I'm going to do for now with that. Now let's do integration.cxx. So this is actually going to be the file that's going to be compiled. And so now we have our trap rule, and we do double star F. Oops, nope, I did not forget one thing. Okay. And then we do a start and an end. Like so. Okay, so now we actually need to, this should return for the trapezoidal rule 0.5 times, is it b minus a for dx, and then we do fb minus fa. And so, and this, you're probably wondering at this point what the heck I'm doing here. And so let me explain. In C++, you can actually pass functions to other functions, and that's what this signature does here. This is a function pointer. Okay, this particular function returns a double, and it takes a single double, like so. And so we can now pass the trapezoidal rule any function that fits that signature. And we can use it, we give it a name f, and so we say f of b minus f of a. And what's really useful about this, if we look up the trapezoidal rule, you'll see here we actually pretty much exactly mimic this particular equation. It looks pretty much exactly the same. And we don't have to specialize it for any particular function. With this, you can write the trapezoidal rule once, and you never have to write it again. So that's pretty handy. All right, so there is our integration file, and we haven't tested it yet. We don't know if it works. At this point, we should test it, but I'm not going to. Actually, we probably should test it. But for now, if we type git status, sorry, don't mind my shortcuts. If we type git status, Git is going to tell us, hey, you have a CXX file and a .h file in here. And so we're going to add these files by saying add everything within this folder. That's what the dot is for. And we type git status now. It's saying, okay, I have added these files. I am ready to commit them. And so at this point, you type git commit. It opens up a text editor, and you can say stuff. And so we say, okay, added in trapezoidal rule. Okay, and you'll see git says it created these two files. There are two files changed, 20 lines added. And if we type git k right now, okay, you'll see that our integration branch has now moved. And it's now pointing to our new commit. This commit has a name, okay? This is a unique identifier. Every commit has one. It's a weird name, I know, but that's the way it works. However, you'll see our master branch has not changed, and neither has the GitHub branch. That hasn't changed either, which is fine. For now, we're going to move over to the function definitions. So we're going to make our .h file, and we add in our header guards. If not defined, okay, and I'm just going to make a nice little namespace here. Functions. And in it, we're going to put, we'll call it pi for lack of a better word. Okay, and now we edit function.cxx. And we have to put in our namespace, function, and then we're going to return 4.0 divided by 1.0 plus x squared. And you notice I did not use the power function. You should know that the power function is really slow compared to multiplication. So if you know what your power is, you should just write it out. It'll be easier, I promise. All right, so now if we type get status over here, and we're gonna intentionally break the Git repository. I'm not going to make a new branch. Okay, I'm just going to make a master. I'm just going to update the master branch. And so it does the same thing. Tells us there's some new files, and so we tell it to add those files, and we can commit those files. And if we add a -m flag, it won't open up a text editor, and we can just put in added the py function. Okay, and we make the commit. If we look at what we've got, we'll see that our master branch has now moved, but the origin master branch has not. Okay, and so here is what. So now what are we going to do? So we made these changes. We want to now share these changes with our friend, Mr. Platypus. I guess we call him Perry, but. So the way we do this is we're going to do a get push. And Git gets mad at us, and I'll fix that here in a second. It's going to tell me it needs a username. So there's my username, and there's my password, and it accepts it, and it gets pushed. So if we look at what we have now, you'll notice that the origin/master branch has now moved. Okay, it's moved from the initial commit. Whereas if we were to look at it over here, in fact, we could just look at these side by side. Okay, you'll notice each one has 2 commits now, but the second commit is different. And not only that, but on the left, the origin master branch has not changed. And so that will end up being a problem, and I'll show you why. But so let's say, okay, we have our integration branch, so let's check out the master branch. Okay, so this is really important. You'll notice if we list the files in here that there is no more integration file. But if we check out the integration branch and we look at the files, they're back. Okay, so that's really important to realize that Git actually modifies your files. So let's say we want the master branch to be where the integration branch is. And this is how we do that. We do a get merge. And since we're on the master branch, this is automatically, it's basically saying, I want you to merge the master branch with the integration, or rather the integration branch with the current branch, which is the master branch in this case, because that's the one we're on. And we do that. And in this case, the merge is really easy. And so it does what's known as a fast forward. So if we look at this one, now you'll see that the integration branch has moved, the master branch has moved up to the integration branch point. And the origin master is still back here. But let's say we don't know that Minty over here has updated GitHub. And so we're going to do a get push. And it asks me for my username. All right, and we get a big error, big nasty error. Okay, it says it was rejected. Updates were rejected because the remote contains work that you do not have. All right, so what that means is that GitHub has changed and you have not updated your information. So to update the information, we have to do a get pull. And it's going to merge our local master branch with the origin master branch. And in this case, the merge is really easy, okay, because there were no conflicts. We didn't modify the same thing. And so if we do an ls in here now, we see, hey, we now have all the function information too. So let's just look at what our get k looks like now. Okay, now it's starting to get a little nastier. So here's the integration branch back here. You'll see that the GitHub is still where it was. It added the pi function. And the master branch has taken those two commits and merged them into one. And now we have to inform GitHub that we have made this. And so at this point, we can now push. Okay, so if we look at what it looks like now, you'll see that GitHub has now been updated to this point. But if we look over here at Minty, you'll see he doesn't have any of this information yet. And so what he needs to do is also another git pull. And his master branch will get updated. Ta-da! There it goes. And so if we look at his git k, so you see that on the right and the left, we now have all the same information. You'll notice the integration branch, which is a local branch, was never shared, but the commits were shared that the master branch was on. Okay, so now that we have those two pieces of information, now we need to write the main.c file. Okay, so we're going to have Perry the platypus take care of that at first. Okay, so first off, he needs to include integration.h, and he needs to include function.h. All right. So we're going to define, in order to estimate pi, we have to integrate from 0 to 1. Okay, so we could call this very simply by doing, let's see here, double pi equals trap of the address. We pass functions by address, so we do function and pi. And you notice how I have two pi's here. That's the usefulness of namespaces, is that I can specify exactly which one I want. And then we tell it to integrate from 0 to 1. And then we're going to see out pi. Okay. Now we can type git status, take a look at this, add our file, say we started okay, at this point now we actually need to try and compile this, and I don't know if this is going to work because I'm coding on the fly here. But so I'm going to do a make file. Since this is small right now, I'm going to keep this simple. We're just going to make a list of files. We need, function.cxx and integration.cxx and main.cxx. Okay, and so if I just do we're going to do files okay, let's see if this works. All right, so we got some errors, but it's actually trying to compile this thing. So That's good. But if we do a git status now, you'll notice, hey, there's a make file. So we can add that. We add the make file and we commit with the short message, say added make file. Okay. Now we're going to let's do this. So we're going to push. So all these changes were done on the master branch. If we take a look at where our master branch is now, we've started the main.cxx file, we've added a make file. Okay, and we are going to push those changes. Okay, and on this side, we're going to go ahead and pull those changes so everything gets updated. So now over here we type make, over here we type make. All right, so now we are going to try and really break this. So we take a look at the first error here. Function has not been declared. Well, that's good to know. What did we get wrong? I have two different namespaces. This one is called functions. And if we look in the other one, here I have functions. So I need to change that to functions. And then in the main.cxx file, I need to change that as well to be functions. Okay. And let's say over on this end, he's trying to debug this as well. Okay, so he sees this and he goes in and says, okay, functions is not what I want. I just want a not plural. Okay. So, whoops, that was wrong. Sorry, my shortcuts catch up to me all the time. So he made a change, so he's going to add that. And if we do make, you'll notice that the function error is now gone. And so now we're going to commit this. Ooh, nano. I love nano. Not really. Let's get out of here. And we'll just use the -m flag because I don't like nano at all. Okay, and he's going to push that change. Okay. All right, and now we're going to see what we've got. We made our changes here. Now you'll see that we made two conflicting changes, okay? On one side, we changed the namespace to be function, and on the other, we fixed it to be functions. One's plural, one's not. And so the question is, how is Git going to handle this problem? Because now we have two differing versions on these two processors or computers. So if we push from the left here, you'll see, oh, it got rejected. Okay, so we do what we did before. We do a pull. Oh, and it tells us it wants to merge everything. And hey, it actually worked. That's surprising. I wasn't expecting that. So, but you'll notice now, while that actually merged, that we now have another error. Because we made these conflicting changes. So yeah, I thought that it did break it. It broke it in a different way than I was expecting. And so at this point you have to say, okay, is that really what we need? So let me show you a new command. So if we do git k and look at this. All right, so fixed function. you'll see I changed it, took it from a plural to a singular. And on this one, we took it from, we took the CXX file from singular to plural and the main file to plural. So let's say now we have a mismatch basically between the header file and the implementation file. So I'm actually going to right click, no, not going to right click. Oh, there it goes. And create a tag. I'm just going to call this the temporary tag. And I'm going to use get revert temp. Okay, so what a revert does, it actually applies the changes backwards in the reverse order. So all the pluses become minuses. And now, if we make it, you'll see that we no longer have the functions error, because if we look in the header file for the functions, it's become plural again. And so really easy. We didn't have to type anything. We just told it to revert those changes because those were not correct changes. And we can push this as well. And on this side, we can pull everything, and now we'll be all up to date. So that's pretty handy. But I really actually need to generate a merge conflict. So how are we going to do that? Let's do this. Let's say we have a bug. Okay, we're integrating from 0 to 2. Okay. Whereas someone else, Platypus over here, introduces another bug going from 0 to 3. So let me show you another shortcut. If you do a git commit -a, that just does everything. So you don't actually have to, it adds everything. Ooh, it's dark in here now. All right, you can't see me. I forgot my camera today. So we're going to push on this side. You got to go. Okay. See you later. And then we're going to try and push from the other side, and you'll see that should fail. Okay, so that fails. So now we pull. All right, now we have bad juju. Okay, you have here a merge conflict. Okay, Git tries its very best to merge all the changes together automatically. However, you'll notice that this merge, it was not able to do this merge. So let me show you what Git does in this case. So if we open up main.cxx, you'll see our file now has a bunch of junk in it. All right, so it shows us both versions. It actually modifies the file, so this will not compile. That rhymed, that was cool. And you'll notice we have a lot of errors in here because it has changed our file. So if we look in here and you see, okay, so this is the head. Now the head is an internal branch, you could call it. You don't actually mess with the head yourself, but it points to the current commit. It always points to the current commit. So every time you switch branches, the head changes. All right, and this is the commit that you're trying to merge in. Okay, and so everything between here and the equal signs is changes that were made by you, and everything below that is changes that were made by someone else. And so at this point, you have to decide how to clean this up. Now, obviously, we can look at this and say, oh, these are both wrong. So we change that to a 1, and we're going to get rid of all this other junk. Okay. And if we type git status, it'll tell us your branch and the GitHub master branch have diverged and have 1 and 1 different commits each. Okay, and now it's going to tell you you have unmerged paths. It tells you to fix conflicts and run git commit, and it tells you which ones, which files are screwing you up. So we git add everything, and then we can run git commit, and this will. What that does is finishes off the merge. Okay, and so we can now push the merge. Okay, now on this side, while he's been doing that, I'm going to take a look-see here. The integration branch, you'll notice he's still way back here. And we have this temporary tag that we don't need anymore. So to delete that, we're going to use the -D there. At this point now we can, we're going to check out the integration branch. And we're going to tell it to merge with the master branch. Okay, and so if we look at it now the integration branch has been updated to the master branch. And so we're going to add in the integration file here, we're going to add in the Simpsons rule. And I don't actually know what this is off the top of my head. But that's funny. Okay, so for now, we're just going to introduce a bug. All right, and we also have to edit integration.h. And we actually technically should have this. Didn't like that. Okay. And so yank, paste, simp. Okay. And we can now take a look at our changes. At this point, if it's been a while and you're like, okay, what have I changed? You can actually type git diff, okay, and it will print out. It's a little hard to read, but as long as you have color on, it's not too bad. It tells you added these lines here, and you added this line here. And you can also run this through a diff tool. Except I don't remember how to actually do that. Anyway, a diff tool is really cool because it actually compares the two files side by side for you, the before and the after. Let's see here, man. Get diff tool. How do I choose the tool? -T. Okay. Get diff tool -T vim diff. Yes. Okay, and so you'll see here that it actually compares the two files side by side, which is really handy. And so you can see on the new version, we've added all these lines that weren't here in the right-hand version. And so we can quit all of that, and we don't want to launch vimdiff again. So that's kind of a cool little trick as well. Alrighty. So type git status, we can update the integration branch. So we update the integration branch. That's hunky-dory. If we look now, you'll see that we're now ahead of the master branch, which is what I want to show you this. So if we do a git pull, first off, it updates the master branch, okay? But it tells you that you're kind of on a wrong branch, on a local branch. And so if you wanted to have your local branch track the remote branch, it gives you instructions on how to do that. But if we look at what our git k looks like now, nothing changed. Right, okay. So we want to check out master. We want to do a git pull. Okay, and it updates. Ta-da! Good. Now let's look at everything that's happened here. So you'll see that we have our merge fix here, okay, from the right-hand side of the screen. But our integration branch is now very different, okay? And just for sake of argument, there's a few things we could do. We could merge the master branch into the integration branch. Okay, so it would work like this: git merge master. Okay, and that makes our, well, you can see our history here. This is what's known as your commit history. It's starting to get a little ugly. Okay, you can see here's the added Simpson, here's 2, here's 3. So maybe there's a better way to do this. So I'm actually going to do let's create a tag. Call that temp. And we're going to git reset hard temp. Okay. So what that does is it moves your current branch back to the temporary branch, or temporary tag. Just so you know, git reset is a dangerous tool, but it can be useful. So just so you know, use it with caution. Let's see here. So now I'm going to show you another dangerous tool that can be really useful. If we rebase our integration branch onto the master branch, instead of merging, what it's actually going to do is it's going to take all of your integration branch changes and place them on top of the master branch. Okay, so let's take a look at what that looks like. You'll see now the integration branch used to be back at point 3. Yeah, it used to be off of point 3, but now it's actually off of the merge. So the base of the integration branch has moved from number 3 to the master branch. It can be dangerous, but it does make for a nice clean commit history with fewer merges. Now there is something that you should never do. So the rebase is actually changing your history. It's changing what your commit history looks like. And most other revision systems do not allow this kind of change. And you can really shoot yourself in the foot with Git if you're too lackadaisical with the rebase command. And the reason is this: if I had pushed my master, my integration branch, and then I had changed its history, now my local commit history looks very different. It's not compatible anymore with the history on GitHub. But since I only did this as a local operation rather than as a shared operation, then it was okay. So I wanted to make you aware of the rebase. It's very powerful. It does take some time to wrap your head around it, though. So read up on it, play with it with your own history. If you screw up, there are ways out of it, and you will learn better how to do things better. So let's take a look at GitHub, shall we? You'll see GitHub now has all these nice little files here, and everything is pretty straightforward. I know this is going long, so I'm going to go ahead and quit here. But anyway, Git is a fabulous tool. I have definitely fallen in love with it, and it is a very complex tool, I should add, and so it takes time to learn. Don't get frustrated with it, but it will help you in your work. You can use it. You don't have to use it for code either. You can use it for reports, or I used it for my master's thesis. I'm using it for my PhD dissertation to keep track of changes and tangents. If you can use a local branch to hold on to a set of changes that maybe or a new feature that maybe you haven't had time to get around to yet, but you get around to finishing yet, while your master branch, continues on and upwards. And then you can just rebase your feature branch onto the master branch, and you can integrate everything together. I personally really like this. Okay, it's called Git Flow. This guy made this blog post back in 2010, and it kind of changed the Git world. But it's a way to keep all of your changes organized and all of your features organized. So you'll see here he has the master branch. And you'll notice the master branch goes boom, 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 boom. Okay? It doesn't change all that much. Then the other main branch is the development branch. And this is a shared branch. The master branch and the development branch are shared, while feature branches are kept local as much as possible. And so you do your work on a feature branch. When you're finished, you can merge that back in the development branch. When the development branch reaches a good point, then you can merge back into the master branch. And so the master branch always contains a viable working copy. The development branch, maybe it doesn't work. The feature branch definitely don't work until they're ready. And as a general rule of thumb, I will say this. If you're working on code, do not commit if it doesn't compile, because it's really frustrating to go back in your history and to find out that particular commit did not compile, which means you have to fix the compilation issues so you can try and find the bug. So anyway, hopefully that gives you enough head start on using Git, and especially with like GitHub integration. There's a lot more to learn, but there's a lot of good documentation out there, a lot of good tutorials, a lot of good books. So go find them, go read them, and they will help you become a very efficient coder. Okay, so that's all I have for you. And I know this was long, but you can break it up. And we will talk to you guys later.